Okay, hopefully you are not awake and Baker, because this next discussion is going to blow your mind. The James Webb Space Telescope instrument that can gaze back to the earliest stars in the universe has just released its first images, and it's hard to even conceptualize how tiny we are in this vast universe and beyond. Our favorite astrophysicist is here to try and make it make sense for us. I'm so happy to have Dr. Hakeem Oluseyi, visiting Robinson professor at George Mason University, and he's the author of A Quantum Life. I am freaked out by the whole space discussion, as we just talked about, because when I saw how vast the space was, and I thought about my problems that seem so big, and it's like my life is tiny, my problems are tiny, nothing matters. What is life? These are the questions that this makes me think. Explain to us how we're looking back billions of years at billions of galaxies. I don't even get it all.
Yeah, you know, it's we don't ever need in our daily human experience to understand the universe as a whole.
Yes.
So our minds just aren't set up to do it.
We can't even conceptualize it.
Right?
I can't wrap my mind around it.
Yeah, so I started thinking of what is a good analogy for the universe of galaxies that we live in. And you know what it is? Air. If you look at the average separation between galaxies based on their size, the average separation between air molecules, it's about the same. But if you wanted to have a volume of air that's equivalent to the number of galaxies in the universe, it's 1 cubic millimeter. So you can think that you're small, but in some scales, you're really big.
I suppose.
And, you know, as humans, there's this huge coincidence in the universe. If we go to the largest thing we know of, the observable universe, and the smallest particle, the neutrino, humans lie right in the middle.
Wow.
Yeah, huge, crazy coincidence. So it's no wonder they're both incredibly strange to us.
Yeah.
Yeah, both the quantum world and the cosmological world. So James Webb is a window onto all these worlds. The microscopic world comes into play when you look at the very earliest times of the universe, because the molecules break down, the atoms break down, and all you have are things like protons, electrons, and light, right? So James Webb is looking at the earliest galaxies, the earliest stars, and understanding how galaxies come together tell us how the universe came together.
This is so, like, I'm hearing you talk, and I'm like, wow, what does it all mean? I think the question, though, that we all want to know, because when I was looking at these images, I realized that these were billions of galaxies and stars that we're seeing.
Right.
And so it seems ridiculous that we would think we're the only life here. There has to be somebody else. And if there is somebody else, if you know about some secret planet that you're trying to keep for yourself and not tell us, like, let me know, because we're planning our escape route in this country right now, I tell you.
Listen, you know, the life that's out there, I don't know if we want to meet it necessarily too quickly, because it's most likely things like bacteria, right?
Okay.
And so where you find liquids is where you may find this sort of life. If we look at the history of Earth, as far back as we could possibly look, we find evidence of life. So that tells me that life gets started really easily and really quickly under the right conditions.
Yeah.
But what's special about Earth is that we have a transparent atmosphere that's incredibly rare in a universe, and a strong magnetic field to block us from radiation. So the life on our planet had 2 billion years to get blasted by sunlight and learn to do photosynthesis to produce oxygen, which allows us to exist.
Wow.
No oxygen, no us. No sunlight on the surface, no oxygen.
You know, so one of the reasons why I love having you on the show is because I just think it's really important for people to see someone like you do this work. And my heart was warmed that an HBCU grad was instrumental in making sure that this James Webb Telescope was functional and successful.
Robinson?
Yeah, absolutely it is. A Howard graduate who wasn't even really trying to mess with the telescope at first. And they had to convince him. But he's the son of sharecroppers.
Right.
And that's just amazing. His testimony and story that he could see a world beyond this world for his career path. Same with you. So I don't know, as I'm looking at these photos, and it gives me this existential crisis, like, what does it all mean? Why are we here? You guys give a sense of purpose to your life when it comes to STEM issues. Just curious your thoughts around all that and the role that Mr. Robinson played in this.
So I'm an HBCU graduate myself.
Tougaloo. You know I know Tougaloo.
Yes, that's right. And I'm currently the president of the National Society of Black Physicists.
Oh, wow.
Yeah, and so I've known Gregory Robinson from when I actually worked at NASA. I no longer do, so I'm speaking on behalf of myself, not NASA. And you know, he's an inspiration, and the way he goes about his job, the way he takes care of his business, you know, and trust me, Webb was no easy task. It has like been the toughest space project that I know of. So you know, kudos to that gentleman.
It's really quite amazing. now we can see, I don't understand how and we talked about this before, how what we're seeing is showing us years in the past.
Yeah.
Explain that to us as best you can. Explain to me like I'm a 5-year-old, because I'm really going to try to follow how these images that you're seeing on your screen right now, how is this showing me what happened a billion years ago here? That's
right. Well, it's the same way when you look at me, right? Light takes time to travel from me to you. So you don't see me as I am now.
Yeah.
You see me like 100 millionth of a second, later than my personal now. And so the greater the distance becomes, the farther back in time you're looking. So when you look at the sun, that light's taken 8.5 minutes to reach us.
Wow.
So you don't see the sun as it is now, you see it as it was 8.5 minutes ago. The nearest stars are light years, so it takes like 3.5 years to get to us. When you start talking about the nearest galaxy, it's 2 million light years away. So here's the real problem. We're so tiny, we think the speed of light is fast. The universe doesn't, right? It takes billions of years for certain objects for their light to get to us. And so Webb has enough collecting capacity, and also the universe stretches the light out. Space is expanding. And so as the light travels through space, it gets stretched out by the same amount space expanded while the light was traveling through it. So light that's visible when it leaves a star, by the time it gets to us, it can be infrared. And that's why James Webb is tuned to the infrared.
And that is so... it would be if you went up to someone in a bar and said, "Hey, babe, I can make you see stars." I'm just giving that. That's free. You can use that one. That's free.
All astronomers been using that for decades. That's all right.
Clearly, I have not met too many astronomers. Yeah. That is really fascinating, though. Yeah. Everything you just said. This is a wild time.
It's nuts. And so what
next are we going to see from the James Webb Telescope?
So much, right? So things that we haven't seen a lot of is studying exoplanets, right? These are planets around other stars. So we've got a hint of that. One hint is what we call a spectrum. So basically, when the light passes through the planet's atmosphere from the star. So the star passes in front of the planet in our line of sight. The light passes through, or it can actually reflect. James Webb gets it, breaks it into its constituent colors, and it can determine what chemicals are present in that atmosphere.
Wow.
So we're looking for biosignature molecules. The other thing it has, which they have not illustrated yet, is an instrument called a coronagraph. So as stars are forming, right, they have these debris disks around them that are destined to become planets. So this coronagraph can block out the light from the star so you can actually see the disk. Wow. And sometimes you might be able to image the planet itself.
This is so fascinating.
Yeah, right?
I was telling you, yes. And I was telling you during the break, every time something in space happens, I'm like, please get us Dr. Hakeem Oluseyi. Yes. So listen, I love that you're an HBCU grad.
Yes,
went to Tougaloo. And if I'm not mistaken, I'm sitting next to a Kappa man as well.
Absolutely.
Is that right?
Yeah,
yes. I love it. Right. Representation matters in these spaces, especially in STEM. So be sure to follow Dr. Hakeem Oluseyi. If you have questions about how you might want to pursue a career in STEM, he's the person to follow. So thank you, sir, for being here.
So much.
I really appreciate it. Thank you. All right, coming up, if you're charged with a crime, an empty courtroom is one of the most dangerous places you can be. I'm going to explain that next. Stay with us.
Wow.